So the last thing that we looked at was how to integrate by separating variables. And the purpose really for that this year is to go into differential equations and the applications of these. So what we're looking at here is the relationship between things happening. We are looking in particular at proportional relationships. So that means that something increases when something else is increasing. But when we did this way back in year 10, we were looking at it in terms of a steady constant fraction. This related to this was a half, okay? Now we're looking at as a rate of change, so it means that it's not steady. It's in some way not a straight line relationship. In fact, usually an exponential relationship. But it doesn't have to necessarily be increasing. It can be inversely proportional, which means that when one thing increases, the other thing decreases. And we have all sorts of formulas that come out of that. So specifically for these, we're looking at situations for things like population increase or decrease. All right, we can be looking at financial changes. We can be looking at, quite a common one is some sort of epidemic. All right, it can be looking at the concentration of a particular element in something. There are all sorts of little bits and pieces that this can actually apply to. All right, the equations that go with this come looking something like this, and because we are talking about rates of change, it's a derivative. So we can have this as proportional. That says that something is changing proportionally according to x. Or we can have this one, inversely proportional. Something is happening in the other way. Or the last one, which is the one we're dealing with, is this one. And what this one says is that it's proportional to itself. All right, something is changing in proportion to its actual self. Okay, so those are the cases we can have. This is the one we are actually interested in. So what happens here is that they will tell you usually which of these cases you've got. That's not particularly difficult. They will normally tell you, but if they don't, then you just have to think, okay, what's happening? Is it increasing or is it decreasing? Okay, we can have negative k. So it can be the negative k means that it's actually going down. It's decreasing as well. All right, so if we have something like this, the first step in this particular problem is to prove that we're in the integration exam, which means that we actually have to do some integration. Now, we should know what the equation we're actually dealing with looks like, but we actually have to show it on the way. So they may say something like, this one. All right, they may say this, and what we're going to do is we're going to integrate it. So this is the integration we're going to show. This is the same as what we were doing the other day, so we're going to take the y's to that side, the x's to this side, which leaves us with dy over y equals k dx. All right, and then we're going to integrate. This one will give us ln of y. This one will give us kx, and then we get this plus c. Now, I said I'd explain why this turns into an a. So what we want to do is we want to be able to say more about this plus c in this particular instance. And to do that, what we do is we replace this with a plus ln of a. Okay? When we rewrite this, we get ln of y minus ln of a equals kx. This changes using our log rules to y over a equals kx. We don't want that ln. To get rid of ln, what do we use? E. So we're going to e it. So we're actually going to say e of ln of y over a is the same as e of kx, which we write as, so those are cancelling, y over a equals e to the kx. All right, here's our constant here. We don't want it over here. We want a y equals, so we end up with this. All right, so what do we need to write? We need to write this. We need to write this. And we need to write this. Those are the parts we need to show. We need to show we are integrating. This is what we get when we're integrating. This is what we are going to work with. Those are the 3 lines you must have to get in. You can't just jump to here. Okay? That shows that you are in the integration paper doing some integration. Now, how do we use it is our next question. So our next question is, if we've got an example like this, okay, so it goes like this. The half-life of 42K. Does anybody know what that is? It's a potassium isotope. Never heard of it. I don't do science. And it's radioactive and it's a nasty beast. All right. Anyway, we don't really care about that. We just want to know the mathematics behind it. Perhaps if we're actually the person dealing with it, we would want to know that. Okay. The DE, modelling this, right, so that says that concentration over time is decreasing by K with respect to the concentration wherever it was in the first place. All right, so that's how that reads. Okay, so the question is, what is the percentage of the isotope remaining after 10 hours? Okay, so that's the question. So, if we were doing this in the exam, what we would need to do is this process here to this. Okay, so we would get the integral of dn over dt, saying we know we are integrating, is the integral of dn over n equals the integral of negative k dt. Now we integrate, so ln of n equals e to the negative, equals negative kt plus ln of n, a. Now we can go straight to it and say that n equals a e to the negative kt. All right? So that part there we need to show. Okay? We made the mistake in the past of just saying, well, we all know this part here, and we do, but you actually have to do some integration to get marks in the integration paper. So, now that we know that, how do we get the answer? Well, so one of the reasons that we want to do this business of making this A is because when t equals 0, or the starting point of whatever this is we're talking about, so the initial value of it, when we put a 0 into here, A is going to be the initial value because this is going to be e to the power of 0. E to the power of 0 is 1. So this is our starting value, okay? So when t equals 1, e to the negative kt is going to equal 0, sorry, that's 0. So A is our initial value. Sometimes they'll give it to you, sometimes they won't. It depends on how hard they want to make it. All right. So the half-life, what does that mean?
Between like 100%, like 50%.
Yeah, so when 50% remains, all right, so when 50% remains, we've got 12.45 hours. Okay, so we don't have an initial value at the moment. So we continue on with what we do know. So if t equals, so if the original value is A, what is the half-life going to be?
Equals A over 2.
Yeah, A over 2, right? So, just writing it nicely. When t equals 12.45, n will equal A over 2. All right, so that's our first hint that we've got. So, what we are trying to do here is we're trying to discover what K is. Okay, so we're going to make this, all right, so A over 2 equals A e to the negative K 12.5. All right, so that means that if we divide by A, we're going to be able to cancel the A's out. Okay, A over 2A equals e to the negative 12.5K. Oh, that's not 5.
12.45.
12.45. Okay. 4, 5. Okay. So that means the A's cancel. So now we've only got one unknown here, and that is that e to the negative 12.45K equals a half. How do we get to there? How do we undo that e? Right, we ln it. So not this side, because that's going to this. Okay, and then we put it in our calculator. 0.5 over negative 12.45. So we put that in our calculator and we get 0.5567. Now, one of the things you need to realise is you need to keep a fair amount of decimal places here because often we're talking in population and large things like that. Anyway, now that we've found K, we actually have what we are using as our equation, which is that n equals A e to the negative 0.05567t. All right? So if we're going to put 10 back in there, 10 hours back in there, we've still got A. So we need to discover what A is. All right? How are we going to do that? So the proportion?
What is the percentage?
No, you lost me. Okay, so what we want to do is we want to put our 12.45 in, all right, so that we've got n equals a e to the negative 0.05567 times 10, all right. We know that this equals what? Calculator. E to the power of negative 0.5567, 0.5731. All right, so it equals 57.31% of the original amount is remaining. All right? We don't know what the original amount is. We're suggesting it's 100%. So if it's 100%, then 57% is what is remaining. Yes? We start with 100%. We're decreasing it. So 57.31% of the initial amount. Oops, NT. Okay? Yeah?